Page 4 of the I/O notes, and now I'm going to show you that bit about the type modifiers. So this is from yet another header file, core_cm3.h, and the cm3.h is for the Cortex M3, that's our header file. That gets included via the lpc17xx.h header file because the 17xx, or the 1768, includes the Cortex M3 processor, so it's needed. And here's one of the lines that you'll find in that file, if you can find that file. So pound define _i. So this is a macro definition, and wherever the _i appears in your program, it gets replaced with volatile const. So this gets cut out and this gets pasted in. That's the way macros work. And so volatile is an example of a type modifier. So type is going to be something like a UN8. Type modifier somehow changes the way the compiler treats it. With the case of volatile, what it does is it tells the compiler not to optimize out reads or writes to this variable. And let's just do a little example down here to show you what I'm talking about. So say this was the code that you wrote. Int x, x equals 10, x equals 11. The compiler might look at this line here and it might say that serves no purpose because x gets set to 11 before any code in your program reads it. So in this case, the compiler might elide, means taking something out, this statement. So there's numerous optimizations that compilers do, and this is one of them. Which optimizations get done depends on the optimization level of your compiler. So to guarantee that that doesn't happen, even if you're optimizing your code, so you include that volatile keyword, and it tells the compiler, even though it looks like that doesn't matter, it does, so leave it in there. And that's the case when you're dealing with I/O devices. You write to a register, and writing to it 2 times in a row can matter. And we have another type modifier here, the const keyword. And const doesn't mean what we think it means. It doesn't mean that it's constant. What it means is any statements in your code that try to assign a value to that variable will not be allowed. So it tells the compiler to disallow writes to this variable. I think in C++ const actually means that it does not change, but in C, if this is a register on an I/O device, say it's the receive buffer register, you read it once and you get the first character that was sent, or the first byte that was sent across the serial port cable. You read it again and you get a different value. So it's not constant, but what it says is don't try to write to the receive buffer register. So given that, this macro, _o for output, we want to be able to write to that address, so it's not going to be const, but just volatile. So we don't want to optimize out writes to that memory location. And some registers are input output, and it actually means the same thing as for the output, so it's volatile. You can't make it const, or you wouldn't be able to write and use it as an output. So the rule of thumb is, rule of thumb is use volatile for memory mapped registers.